Now can I start?
Yes, sir. Yes, sir.
Okay. Okay, guys. I already discussed allylic substitution, but here today we will go in allylic substitution NBS. We will go in a mechanism part also. Okay. Why it is happening? Okay. And this reaction is also in. Okay, one second. Praswal is coming. Hello, Praswal. Now I am starting the class. Okay.
Okay, sir.
Okay, guys. See, this is a allylic substitution. I am starting now. What happen if you have any alkene group attached with the alkene group? Just attach the carbon with the alkene group. That is the allylic carbon. We can say alpha carbon. Okay, attached to this alpha carbon, all hydrogen are alpha hydrogen. Also, you already know. Okay. So in this reaction, what happen? When halogen will, if you will take, if in this reaction, if you will take halogen at high temperature, yeah, NBS at light presence, high temperature, yeah, heat, yeah, you will take SO2 Cl2. So in this case, your CO chlorine will come at the allylic carbon. Okay. In this reaction, we will observe now today. Okay, that is why we are going to study this. Okay, guys. If you have halogen at high temperature, many 400 to 600 I already discussed in the class. Don't say like this 200, 300, no. Only 400 to 600. Okay, NBS in the presence of light at high temperature, yeah, SO2 Cl2. In this case only you will take allylic substitution reaction with alkene. Okay, I am written also here two types of reaction. If you observe, okay, here chlorine will be there in the presence of CCl4. Here chlorine will be present in the temperatures 400 to 600. Upper side, if you observe here, here addition reaction will happen. Why? Because they will remove the alkene and they will make the alkane. Means their addition here addition will happen. But because of high temperature here, alkane is maintained, but only chlorine will come to allylic carbon. That is a substitution reaction. So from this carbon, they will remove one hydrogen, and chlorine will come. That is a substitution. So because of this chlorine, the presence of 400 to 600 temperature, here substitution will happen. Okay, and here you also observe this carbon is alpha carbon. In the presence of high temperature, chlorine will come on this carbon. Okay, guys. Now see. Now I will teach you mechanism part in the this field. Okay, just suppose that uh, one second. Suppose that you have CS3 toluene, you can say, plus Cl2 at 600 degrees Celsius temperature. So here as the same result you will get. What? Add, because this carbon is a alpha carbon. So here same thing you will observe. Here C2Cl will form plus acid. Okay, the presence of high temperature. Okay, guys. Now I will moving on the mechanism part. Okay, how it is happening. Okay, okay. See, first what happen? First initiation will happen. Initiation means your reaction will start. How? You have chlorine in the presence of high temperature. If you have chlorine in the presence of high temperature, so what happen initially? Your chlorine will break in the free radical group. Okay. My Y's या notes are clear, na guys? There is no problem in this case. Y's या notes are clear. Okay. Wind, fan sound is disturbing so much. Yeah, it is manageable. Okay. Okay, guys. Okay. If you have chlorine at high temperature, the chlorine will make free radical chlorine. Okay, and this free radical chlorine is very high and stable, so that is why it will go to, I will take here compound propane. Okay, C2H double bond CH CH3 plus free radical will, group will come here to this propane. I am taking here propane. Okay, okay guys. So this free radical chlorine will come to this propane, and because of, see, this chlorine free radical group, it will take one hydrogen from this compound. Okay, so now question is will arise कि from this which carbon, from which carbon this chlorine will take hydrogen. See, first your chlorine will not add in a compound. No, first he will take hydrogen. Okay, because already your compound is normal, stable, so there is no reaction will happen between them. So that is why first chlorine will take hydrogen. Okay, so which hydrogen you can give here? This 2 degree, it is 1 degree, it is a 1 degree. I will write here from uh, if you give the hydrogen from this carbon, if you give the hydrogen from this carbon, so here suppose that from here you will take the hydrogen, but from here hydrogen will go as a free hydrogen. कि hydrogen will take their own electrons. Okay, because of that carbon have one electron is on side. Okay, now what happen? See guys, you can say sir 2 degree carbon free radical is also very stable na, but why not making? Why it is a question here? Because if you observe proper way here, so you can see here double alkene group is here, here alkene group is here, and here free radical carbon is here. You know, it is a resonance. You know, this is more stable comparing to 1 2 degree this thing, because this thing are related to inductive effect. But you know, resonance is more stable. So because if you are taking the chlorine from this carbon, your structure will effective more. 1 second. Hello, ma'am. You are joining the class? Okay, leave it. Okay. So actually, what happened here? This is a resonance stabilis. Okay. Okay. This is a resonance stabilis. Okay. That is why hydrogen will replace from the this carbon. Because of it, this alkene and this free radical will make resonance. So that is why it's more stable. That is why we remove the hydrogen from this carbon. Now this radical free radical carbon intermediate part is very stable. So that is why this carbon, this group will go to chlorine, and it will take the chlorine. Okay, and from here chlorine will go to this carbon, and again you will get the free radical chlorine. So that is why that is why here you will get alkylic substitution reaction. Okay, that is why you are observe here alkylic substitution reaction because of this mechanism. Okay, okay guys, I will say, because see what happened. You can say sir this chlorine will again is a free radical chlorine. Huh? What happened? Again this chlorine will attack on this. Uh, you can say this process going on. Why? Because this chlorine will attack on the again in the propane group. Again propane will become free radical. Then again this process will going on. Why? Till what time? When your chlorine amount, your propane amount will not finish. Till what time it is going on? Okay, that is a mechanism. Okay, and the last what happened? Okay, and now this that is I'm saying ki here what happened here? Ki in the last you can say ki Cl2 in the presence of 400 degrees standard Celsius. This compound already you get. Okay, again this chlorine will react with the compound, and in the last you will get, already you will get this, and this clone will again doing same thing, and you will get in the last HCl. Why? Because I already have, because this chlorine free radical will take one hydrogen from here, na free radical hydrogen. So because of this, both are making HCl here. Both are making here HCl. So this HCl you will get as a byproduct. Okay. Okay, guys, I am writing here one question. Please try. Then I will explain you. Here, what product will be possible here? Yeah, how many number of product will be possible? Just tell me. Is a is a compound. This is a chlorine. Presence of 600 Celsius. So in this case, how many number of compound you can expect? Okay, and what product will form here? Just tell me. Then I will tell. I will just give you 1 minute. Just think. Okay, look. This carbon is a alpha carbon. You can say, sir, according to the mechanism, according to the reaction, you can say, sir, here chlorine will come in this carbon. This okay, there is no problem here. Okay, but one product also form. How? Because if you see chlorine will break in the free radical chlorine group, and this chlorine will go towards this. Sorry. So what happened? This carbon will get the free radical because of chlorine. Because this chlorine will take the hydrogen from here. Okay, so whatever hydrogen is here, they will take the from hydrogen here. So what happen? Here you will get the free radical group. Okay, plus HCl. Actually, what is the problem here? This alkene group and this free radical group are resonance. Because of that, because of resonance, this double alkene group will come here, and this free radical electron will come also here because of resonance. This is possible. So in this case, you will get two types of group. Okay, once here you will get the electron here. Once time you will get here because of resonance. So that is why if you are adding in both case uh, Cl2, in both case if you will add Cl2, so what happen? You will get here Cl, also here also Cl you will get. Okay, but what is the major things are here? Key, this is a major and this is a minor. Both will be formed. Two answer is right as well. And this is major. It is a minor because resonance is established. There is no problem. But this carbon is a 2 degree and this is a 1 degree and it's a free radical. Observe. So that is why this is more stable. It is more stable compared to first one. So that is why this compound will form here more, and this will form minor. Okay, but both are possible. Okay, guys, both are possible. Okay, both are product. Okay, guys. Okay, Prajwal, I will repeat. See, you have this function on this carbon group. Okay, here alkene is double bond is here. Okay, we have chlorine with the presence of 600 in Celsius. So according to reaction, your chlorine will go to alpha carbon. Okay, you can say, sir, here chlorine will come. This is a reaction. Okay, but what happened actually because of mechanism? If you go in the mechanism, that is I'm telling. Okay, because of mechanism, this chlorine will is a free radical. Because of that, you will take the hydrogen from the 2 degree hydrogen from 2 degree carbon. There is no problem. That is why free radical electron will come here. But what happens? This free radical electron and this alkene have resonance. Because of resonance, they also can change the shape. So this radical electron, see if this bond will, if we take here, so this radical move here, yes or no? If I will, I can shuffle now because of resonance. So if this double bond will come here, so this free electron will come here on this carbon. Now this is a 2 degree. Now this is a 1 degree. Okay. So in both places, chlorine will come here. Okay. But why 2 degrees measure? Because resonance in both cases possible. Okay. Yeah. And 2 degree why is stable? Because here you have alkyl group. Because of that you will get the I plus I effect. Okay. Because 2 degree free radical. See, already in both case resonance is possible, but 2 degree free radical is more stable. That is why it will form major amount. Okay, both will happen, but it's a major amount. Okay, okay. I will go in the next. Okay. Now I will tell you about NBS. Actually, in the NBS, what happen? They will give you low concentration of bromine. Okay. Here, what happen if you have same propane, NBS, the presence of light या heat. Okay, so they will give you same thing allylic substitution, but here you will get only bromine. Okay, plus HBr. Okay, why it is happening? I will tell you in the mechanism part. First, I will explain you some thing about NBS process. Okay, see, first I have one compound. Okay, this I have. This name is. You asking me to me what is the name of NBS? I will write here today. Okay, don't worry, and I will make the diagram also. What happened from here? This OH will go from here. OH will go because of in the presence of P2O5. Because of that, you will get the this relation. Okay, see here, double oxygen is there, and one oxygen will connect to both. Okay, like this. Then I will put again ammonia. Because of ammonia, again water will. You not I cannot say water, but H2 will come outside. Okay, and it will make CH2, CH2, C double bond, C double bond, and here N will come, NH will come. Okay, that is a so succinamide. That is a name. What happened here actually? When you have this compound, okay, in this compound, if you will put whenever you have this compound, we just see this NH bond. If you put here Br2, yeah, HBr, whatever you put here, what happened because of that? This H will replace here and will come here Br. Here NBr. That is a NBS. And bromo succinamide. That is a diagram. Okay. Because here bromine is connected to nitrogen, that is why we are getting very low concentration of dehydration. Yeah, you can say here dehydration will happen 2 times. Okay, you can say. Okay, in the presence of P2O5, that is not a concern. Don't worry about that. Okay, why I'm telling just how this is compound is coming NBS. Okay, and this nitrogen will connect to Br. Okay, actually, na after P25, they will observe here this HOH will release. That is why they saying it is a dehydration. Here water will lose. Again here because of ammonia, here water because from ammonia they will take two hydrogen. From here they will take one oxygen. This. That is why again you will get only NH here. That is why they mention it is a dehydration in both cases. Okay, you can say this molecule is a anhydrate. Okay, this is a way to remember. Okay, but it's not a dehydration. Okay. See, this is a name N bromo succinimide. Succinimide. Okay, this is a diagram of NBS. Okay, guys. If you want to make the diagram like what happen if you I will put here HBr. So they will actually what happen if you are putting HBr? What happen again? They will make HBr2 and they will make this compound. Uh, I will make it like circular diagram. Okay, I will not draw carbon here. They will make like this. Okay, if you are putting Br2, they will convert into NBS. Okay, this thing will okay continue because here Br concentration is very less, so that is why you are getting allylic substitution here. Okay, so now what happen again here? I will make a diagram. I have NBS in the presence of light. Please tell me what what product will form here. Just suppose, just think. Then I will make. Can you? I'm saying just guess what product here will be formed again. Again, you will get here two product. Okay, because see, this is the alpha carbon. Because of here Br is here. Because of light, Br will form in the free radical group. Because of that, in the second degree carbon here you will get take from here hydrogen. So here free radical will come. Free radical electron will come here. Because of that, again halogenesis will happen. So here double pi bond will come here. That is the free. So because of that, if you are taking bromine here, so here you will get again two types of product. Here again Br will come here, and again here Br will come, and again this 2 degrees measure here, and this 1 degree is. So just remember this. See, because now we are using NBS because in the NBS you will get the very little amount of bromine. Because of little amount of bromine, here substitution reaction will happen. Otherwise, in normal case, your addition reaction will happen. Okay, but because of low concentration of bromine, you will get here allylic substitution. Okay, I have one good question here. I will make just think about it. Okay, guys, I may here toluene. Okay, in the presence of NBS. Okay, in the presence of light. Just tell me here how many products are possible if Br water is used. Yeah, here one is formed, but here minor product, small percentage. You can say 1 or 2%. Four types of possible here. Yes, small amount. Four types of is possible here. Yeah, because of resonance. Because the see here what happened? You can say sir, this is the answer here. Okay, plus HBr. You can say. But what happened because of resonance? You will get four types of free radical group. I will make here. Okay, just see. So what happened here? Guys, see here one resonance is different type of resonance. This is possible. One is this see both are same dice only change, but products will be same here. So one, two, three. So here you will get three types of product. Okay, three. Okay, but what is the problem here? I will tell you. See, this diagram is aromatic. If you see in the benzene, you are making 6 5. That is aromatic. But other product, other resonance structure is not aromatic. You can observe here. Other structure is not a resonance. Because of that, because of that, they will not form so many compounds. Their percentage is very less, 0.1%, 1%, 2% only. And that is why it is a major product. Because the aromatic is more stable compared to all one. That is why it is making major product here. Okay, guys. I have one more question I will ask here. One sec. I will have to teach you one new topics. One second. This allylic substitution action is complete, guys. Okay. This allylic substitution action is I complete. Can I start SN1 mechanism? This introduction part. Question. Uh, see, I just in this. See, in a Haloalkanes, na, if I will teach you na some mechanism like SN1, SN2, SNI, then I can discuss with question with you. Okay. Okay, because here question will depend on mechanism so much. So that I am saying, just I will teach you mechanism part 1 to class, then I will discuss with you PYQs. Okay, then I will discuss with you PYQs. Okay, now guys, I am this introduction here in the online class, and offline when I'm coming in a school, I also have teaching in a good. Okay, if you have doubt, just I'm discussing here as an introduction part. Okay, see guys, in your Haloalkane chapter, if you are observing, I'm if you are observing in the chapter, you will observe SN2, SN1 mechanism, SNI. What is the meaning of that? Nucleophilic substitution reaction. 2, 1, Sometimes you see I means intermolecular. 2 means your molecularity will 2. SN1 means your molecularity is 1. Okay. So this thing we have to discuss in this haloalkane chapter. When I discuss now this haloalkanes part, okay, mechanism 2 3 mechanisms, then I will solve you PYQ in front of you. Okay, because PYQ here depends on mechanism also. Okay, just 1 second. I will make comfortable. So I'm starting. See, first I'm starting SN2 mechanism. Okay, uh, SN2 means substitution nucleophilic bimolecular. What is the meaning of this? Okay, here you have substitution will happen. Nucleophilic will come. Okay, nucleophilic will come, and because of nucleophilic substitution reaction will happen. And bimolecules means here for the reaction, two molecules will collide to making the product. That is a bimolecule. Okay, molecule is 2K. Okay, you can observe here. Okay, you can observe here, guys. See number, whatever number I'm mentioning here, that is also including your molecularity and a grade determining state also. Okay, I will tell you. Don't worry. I have notes in this in the after the mechanism. Then I will show you. Okay, one line every line. Don't worry. First, I will discuss with mechanism. Okay, I have NOH group nucleophilic. See, I have NaOH. Okay, in the presence of methyl iodine. Okay, if you observe here, this NOH in a OH is a your you can say what happened? Sound is
Told
not. So this sound is not coming. Now it is okay. Now it is also follow. Projects. Now it is also follow. So just tell me now is also follow. Guys, can you tell me? My voice is clear. Anyone can please respond. Okay. Now it is also
yes, sir.
okay. I do not. Yeah, just give me 1 minute. I will come. Just give me 1 minute. I will take water. Just 1 minute.
Mouth wave is coming.
What?
Huh. Okay. Okay. Now we're starting. Now my voice is clear, guys.
Yes, sir.
Okay. See, in the NOH, what happen? This OH negative will act as a nucleophilic. Okay, and it attack on the back side of the methyl iodine, not from iodine side. It will come from carbon side. Why? Because you know already iodine more electronegative comparing to carbon. So that is why here you see here polarization will happen. I'm not saying कि electron will take here polarization will happen negative and here positive. Okay, because of that on this carbon positive, this OH negative nucleophilic will attack on this carbon backside. Okay, like this you can see here in the diagram. Okay, here what happened? This OH will approach to carbon. Okay, because of that what happened? this I negative will release because backside from backside OH will come and I negative will take the electron because of carbon distance will complete by OH. So that is why I will go outside. Okay, here and here you will get HOC triple CH. You have to see here. Okay, that is a here SN2 mechanism. It is happening, and here attack of the nucleophilic from the backside. Okay, always. And what I mentioned here, that is they are mentioning ki OH, their negative side, they are attacking on the back side. That is why from back side you are making the OH compound with CH3. Okay, sir, priority plus I negative. What is the meaning of priority here? I will discuss all these things. Just wait, na. In this, I will discuss. Don't worry. I have, guys. Don't worry. Yeah? I have. I will discuss further. Okay. See, in this nucleophilic substitution reaction SN2 mechanism, your inversion of configuration will happen. Because already I am showing your OH will attack from backside to carbon. That is why it is an inversion of configuration. Okay, here some characteristics are there for SN2 mechanism. It is a one-step reaction. In a one step, your reaction will complete. Okay, here rate is proportional to the concentration of halide and concentration of nucleophilic. Means OH negative concentration and RI. You can say RX. Okay, depends on you. Okay, so here your rate will depend on the halide. Okay, you already know, guys. I already discussed chemical kinetics. Key in a if you have one step reaction, in this case your rate directly proportional to halide and nucleophilic concentration. That is I am writing here. Rate directly proportional to Rx concentration and nucleophilic. And it is a first order reaction. That is why their power is a 1 1. Okay, and order of reaction here molecularity is already equal by because they are only one step reaction. That is why order of reaction and molecularity is equal. That is a 2. Okay, in SN2 reaction rearrangement not possible because of it is not, it is one step reaction. Yeah, it is not possible because see rearrangement I told you already ki when you have possibilities ki you have more. See, actually what happens in the mechanism part sometimes, if you have option you can make more stable compound. So in this case you can rearrangement. Okay, but here in SN2 mechanism only in one step reaction. Okay, that is why here rearrangement is not possible. Inversion of configuration take place in the reaction because nucleophilic attack from backside to leaving the group, and living group is iodine here. Okay, and OH negative coming backside. That is why inversion of configuration will happen here. Okay, there is no relation between the inversion and RS configuration. I will tell you later this in a isomer what is the meaning of what is the saying. Ki here you can say uh, actually here what happened. I will tell you later. Okay, this part RS configuration. Okay, don't worry. I will tell you. Okay, don't worry. That's all. Okay, I will tell you this line meaning. Okay, I also forget. Yes, some factors are there in SN2 mechanism. I will discuss with you. Okay, see, I negative या Br, Cl, AF negative is a living groups here because they are leaving the alkene. Okay, okay. So iodine is the most living group combined to bromine, chlorine, and fluorine. Why? Oh, yeah, sorry, guys. 1 second. My laptop battery is not there. Now it is. See, here living group iodine is more okay compared to Br and Cl and F negative. That's the why you can see here I'm written here IRI is more preferred compared to RBr, RCl, RFY because already you know guys I negative CF negative is very electronegativity group. Okay, and Cl negative also. So they will make the very good compound with the carbon. So okay here so in this case chlorine also leave the alkene. There is no follow. But compared to iodine, iodine is a very big element and their electronegative nature is less. So because of that, iodine will leave earlier compared to Br and chlorine and fluorine. So that is why this is the order of leaving group. Ki iodine will leave very early. Background music? Here no music. Hai. So iodine is more early because I'm saying water sort. It is possible because people are living somewhere when are doing some work, so it's possible. Yeah. I'm not sitting in studio, na, so sound will not come. Little bit sound will come. Okay. See, so iodine negative will leave very early compared to bromine and chlorine and fluorine. Okay. So please remember this thing. Okay. And Ri also because of I will leave early. That is why in a case of Ra also I will early leave. So because of that, you can say that Ra is a reactivity in the case of SN2. You can say that Ra is more reactive compared to RBr, LCl, R. Okay. That is a I make here 1 degree, 2 degree, 3 degree. What are you asking here? See, what is the see I am making here. You have three types of compound: 1 degree, 2 degree, 3 degree. Okay, chlorine will be here. So they are asking, ki, what is the problem in this case? Okay, you can observe here, guys. Here, na, if alcohol will want to attack on the first degree, so here it can attack. Okay, on this carbon, easy, no problem. Okay, if they are want to attack on this carbon here, see, actually here, what is the problem? If alcohol want to attack on the central atom which is connected to Cl, so it he has more chances to attack on the carbon very easily. But what problem in the third degree? You are covering from the methyl group from three sides. So here steric hindrance is more. So because of that, for alcohol to collide with this carbon is very difficult here. So that is why we are saying in the 3 degree is very little chance ki, here our alcohol will attack. That is why 2 degree and 1 degree is possible. And that is why you can say ki 1 degree is more prefer compared to 2 degree and third degree in SN2 mechanism. Okay, why? Because it's a hindrance. Yeah, because the alcohol have a problem na, to attacking on the carbon because of staying hindrance. Now see, when you get the product, when OH will collision with carbon, proper orientation. So here three carbonyl group are there. Because of that, there very little chance to attack on the carbon. That is why because of steric hindrance. So that is why here little you can say little chance. But in 2 degree, 1 degree is more chance. So that is why 1 degree is more preferred here. Okay. And they are saying कि polar aprotic solvent favor the SN2 reaction. Why? Because if you use a water polar aprotic solvent, your nucleophilic substitution becomes stable. We use polar aprotic solvent. I already discussed na with you guys polar aprotic solvent so many times. I told na in polar aprotic solvent. I told I think I remember that. I told if you're taking polar solvent, aprotic solvent. So in this case, you already know na what happened. One second, one second. I will tell you one thing. I discussed that day. Na, yeah, you remember? He have 4O in the center. You have sodium, so it will trap this. I think polar aprotic solvent. I discussed with you guys. How much? 2, 4, 6, 8, 4, 12, 12 crown, 4 ether. Because of that, they will trap the sodium. That is why we are prepare aprotic solvent here. Okay, because of any positive they will develop trap. Yeah, positive trap they will trap. Because of that, OH negative will attack easy way. So whatever I'm written here mechanism NOH initially. So here because of Na positive will trap because of polar aprotic solvent. So OH will attack easy way. So that is why in this case we are using polar aprotic solvent. That is why they are mentioning here polar aprotic solvent favor the SN2 reaction. Okay, okay guys. if you are taking UH2 water, polar protection, what happen? They will attract the OH negative. So how your nucleophilic will attack? So that is the problem. That is why we are prefer here polar aquatic solvent. Okay. So guys, today I discuss whatever I have content for you guys. Okay. That is a SN2 mechanism I discussed with you guys. Okay. In this case, so many things are there. I'm not saying it is complete. So many SN2 things are remaining is there. I will discuss remaining part also. Okay, in the class, a Monday class. Okay. Uh, yeah, I know. Josie part. Yeah, I have to discuss. In a online lecture will go very fast. In a, when we are teaching, I'm thinking just 1 second. Yeah. Yeah. Students, listen. I will teach it. Okay, don't worry. I will upload as a notes. Okay. Uh, some part I will discuss with the reaction part. I think I forget. I will discuss here. Okay. Uh, Harshit, I discuss some mechanism part. Then I will discuss with you Haloalkanes PYQ. Okay. I will finish SN2, SN1, SNI mechanism. Then I will discuss with you PYQs. Okay. Because we are using this mechanism also in the during the question. So that is something. Okay. Just wait for 1 to class only. Don't worry, guys. We have a class. Okay. Don't worry. I will solve the question. Okay. Hmm. And forget to tell the in the class some compounds I will discuss here. Okay. Suppose that I have alkene. Okay, like this. And we have see here X2 means Cl2 या Br2. Okay, in the presence of CCl4. So you know what happened here? From here, if we have alkene, if you will use X2 halogen group with the presence of CCl, you can make what type of alkyl halide? You know, initial halide, halide. You know what is the meaning of see? If you have alkene group, okay, and you will put halogen group X2. X2 means Cl2 or Br2 in the presence of carbon tetrachloride. So in this case, you will convert alkene to vinyl dihalides. Okay, means on this two carbon, both on the both carbon, you will get the excess group. It is the addition reaction. You can say it is the addition reaction. You can say it is the addition because here I am adding here element. So you can say it is the addition. Addition reaction. You can say. Okay. One day uh, I think one day Harshit asking to me one question. Uh, try halide. I think try hello. I think something you asked na that day, Harshit. I forget what you asked me that day. I think try hello. You asked me na that day. Ki, sir, this is the term or not. Try hello in the class. Try hello, not terminal. You're asking. I think try hello that day. Okay. 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 When I'm discussing vinicial D halides, aryl halides, that day, yeah, I think you're asking to me. Yes, sir, mono halides are there, D halides are there, tetra halides are there. So, sir, you tri halides also there. No? Tri halo means if you have carbon, on the one carbon, if you have three X group, that is a tri halo. You're asking, I think that. Okay, forget. Okay, don't worry. So, what happened here? I'm telling here. Yeah, first one, just give me because I'm covering because I will give the question hierarchies. Simple question Monday. Okay, don't worry. GOC I will complete. Okay, don't worry. I will discuss with the assignment paper as a GOC part. Today I because I'm doing very fast because of hierarchies. Okay, don't worry. First of all, I will do. In the online class, Monday to Thursday I have online class. Okay, for you guys. I will take care GOC question. Okay, don't worry in the class. I will not teach here. You physics sir will not take. Physics sir will teach you only offline. Okay, so that I'm taking. Don't worry. Don't worry what happened here. When you have double bond with between the carbon, if you apply X2, because of that you will get the initial D halides. Means in both carbon you will get the halogen group X in the presence of CCl4. That is called initial D halides. Okay, please write. Okay, please understand this concept. Okay, and if you have alkyne group also, if you have alkyne group also, you can get also again addition. If you have that SCCH in the presence of X2, you have X2 in the presence of CCl4. So again, you will get the addition reaction. Initially, halide like this. Okay, again you will do X2 in the presence of CCl4. Again, you will get. Okay, you can do like this. Okay, this is the addition reaction. Okay, and one thing I have to tell also, whatever I forget to tell in the class, I will tell you now here. Okay, suppose that I have to make vinyl halides. Okay, suppose that I have CS triple bond here. I am putting here HCl in the presence of copper chloride. So what happens here? You will get only one carbon on the this carbon only. So in this case, you will get only one chlorine here, not two chlorine, because we are applying here HCl in the presence of copper chloride. In this case, we are presence of CCl4 we are doing. That is why we got in 2x on the. You can say it is the addition reaction, but here in this case, we get only one Cl only here. Okay, you can say it is an electrophilic addition reaction. You can say it is a electrophilic addition reaction. I don't worry, guys. I will make proper clean notes. Then I will send you. Okay, don't worry. Remaining notes I will send you night, and these things I will write proper way. Then I will send you. Okay, so you can read properly. Okay, what happened? I will discuss something here. Just wait. Suppose that you have copper bottom triple bond, and your copper two bonding is here. See what happened here. If you delete this bond, so one carbon will get the negative charge, one carbon will get the positive charge. Okay. So because of that, what happened here? Suppose that it will get the negative charge, it will get the positive charge. So what happened? This chlorine will be negative charge, so it will go to on this carbon because of positive. So here, if you observe here, it will make C2CHCl. You can say it is a electrophilic addition action. Don't worry, I will discuss this part mechanism also. I someone SN2 after electrophilic addition is also involved in the, I think, hydrocarbon. triple bond C, CH2, Br. You asking this now? There is right. One bromo. Okay. Three carbon. Fine. Y N is common name. I don't know. Yeah. Common name. I don't know. Okay. Okay. I will check. I will check this common. Not this compound. I will check. I will check this common. Okay. So please guys, in the presence of acids, copper chloride, you will get the initial only means only you will get only one chlorine on the one carbon only. Okay, in this case only. These two reactions I forget to tell you today. Okay. After that, I think according to me, Haloalkanes part, I think preparation part, I think according to me, I think it is clear now. I think I discussed all reaction related to preparation part. I'm telling. Okay, only now it is the only remaining is uh, preparation part. Sorry, a mechanism part, and what is the other mechanism and properties will be remaining a haloarenes. This topic, three topics I have to discuss now. Okay, so the remaining thing. So, okay, guys. Now I'm ending. Okay, now I discuss with you guys what we can say. I'm discussed already the preparation of haloalkanes. Okay, so in the next class I will discuss you SN1 mechanism or whatever I left in the SN2 mechanism. I also discuss. Okay, I will share the notes now in a 5 minutes, and this one page I will edit, and tomorrow morning I will send. Okay, and the remaining notes I will send. Okay, don't worry. And alkyl substitution also I will send you. Okay, guys. What is the physical state of fluorine? Normally it's a gas, no? At a room temperature, it is a gas. How to mix fluorine? It depends on how you are doing. See, if you are, I'm saying already, if you are doing methane with fluorine, in the presence of heat or light, you will get more heat. Okay, in this case, you will get more heat. Uh, so that is why we are not preferred. That is why we are using alkyl exchange method. And I think I'm discussing the class exchange method, halide exchange method. We are using AgF, mercury fluoride. In this case, you will use alkyl fluoride. You can make. No. If you mix like this, so no, in this case, fluorine will not. Uh, in this case, fluorine, mix. No. In this way, we cannot mix because fluorine is not a good solution. If you mix with, it's not a good because if we got some heat now because of that, so many heat will release. If it got some, so I can say the room temperature is at 25, but already it's not a room temperature. If we got little bit heat also, now it will fly. So it is not okay because methane also is a methane you already know is as a fuel. So that is why we cannot mix normally. It is for methyl blender. Why you making glass here? How you mix how you mix gas in a solid? For solid you have to decrease the very low temperature na, for fluorine. For solid case, so if they will get heat na, then they will get, yeah, sunlight will come. If you will do this reaction in the sunlight, so obviously they will blast as a bomb. Okay, so if you will do in the presence of light, sunlight, yeah, if you are focused on some beam of light also, so it is very dangerous reaction in this case also. Okay, okay, guys. GOC part, please, guys, believe me. I am teaching you Haloalkanes. Why? Because I have to give the question on Monday, Haloalkanes. So that is I am giving. But Monday and Tuesday, I promise you, I will discuss with you guys GOC question. Of course, your assignment question. At least 3 class online I will take for only GOC. Don't worry. Haloalkanes I will teach you in offline class online in school, and GOC I will discuss next week 100% in the online class. Okay, don't worry. Okay, assignment and question paper and question answer I discuss with you. Don't worry. Okay, don't worry. I will discuss with you GOC part. Okay. Now, guys, we can go. Okay. Okay, Hasif, can you switch off the recording? Okay. Okay, we will meet today tomorrow. Okay.